So yesterday we looked at the law of sines, and we could use it to solve for a side or an angle in any triangle. What we're going to look at today is called the law of cosines, and similarly, it can also be used for any triangle. It doesn't have to be a right triangle for this law to apply. So let's see how it works in using it to solve for a side. So here in this first example, we've got a triangle, and we don't know a whole lot of information about this triangle. We basically just have these two sides given to us, and angle B is given to us as 100 degrees. And what we were asked to do is find side B. And so we're going to use the law of cosines to help us figure that out. So the hardest part about the law of cosines is just getting it set up. At first, it's going to seem kind of overwhelming, but it will get easier the more that you do. So we're going to solve for b. That's our unknown, so we're going to start things off with b squared. That's what's going to go on the left side of our equal sign. So b squared equals, and what follows always works the same way. So what follows is, and this is going to look a lot like the Pythagorean theorem here, what follows is the other two sides go in these parentheses, and we're going to be squaring them. So we're going to have 5 squared plus 7 squared. Regardless of the problem that you're on, the other two sides are always going to go here. So at this point, it does look a lot like Pythagorean theorem, but remember, Pythagorean theorem is just for a right triangle. Unfortunately, this is not a right triangle, so there's a little more complexity involved here. So next up, we got minus 2 times the product of those two sides, 5 and 7. So another thing to point out, these two sides will always repeat. So the same numbers that go in these parentheses will be the exact same numbers that go in these parentheses in every problem. So minus 2 times 5 times 7 times the cosine of angle B. So we actually know what angle B is. It's 100, so we're going to put 100 degrees here. So b squared equals 5 squared plus 7 squared minus 2 times 5 times 7 times cosine of 100. So that's what b squared is. So to finish actually solving for b, in this part I'm going to do on my calculator. If I can find a calculator. So here's what we can do. We could go through the trouble of simplifying 5 squared plus 7 squared. We could simplify the 2 times 5 times 7. But honestly, like if we've got a calculator, that's a whole bunch of needless work. So what I'm going to do on my calculator is I'm going to skip to the part where I square root all of that. So notice that on the left we do have b squared. So to finish solving for b, I do have to use the square root. So b is going to be equal to the square root of everything I've got on the right hand side. So what I'm going to do here is just copy it over exactly as it appears, parentheses and everything. Times cosine of 100. Alright. So b is equal to, we'll say about 9.3 if we're rounding to that first decimal place. So b is approximately equal to 9.3. So again, what I've done there, once I have it set up, since I'm just trying to solve for this b, notice that it is squared, so to finish solving for b, we have to square root both sides. So that's what I've done on my calculator here. You're welcome to simplify that, step by step, but if you do that, these problems will become quite long. All right, let's move on to a triangle in which we've got to solve for an angle, because those work a little bit differently. We set them up the same way, but it's not quite as simple as just taking the square root of both sides. So next example, we still got a triangle, of course, but we don't know any of the angles. We got all the sides known, but we don't know any of the angles. So just a heads up, we will have to use the inverse cosine at some point since we are looking for an angle. So the inverse cosine will come into play here. So in this problem, we're asked to find angle A. I need to know what I'm looking for in order to properly set up the law of cosines. So if I'm looking for angle A, that's my question mark. If I'm looking for that, I'm going to start with the side opposite that angle. So I'm going to start with 10.5. So I'm going to have 10.5 squared on the left equals. Just like I said before, this next part always works the same way. It's the other two sides squared. So 12 squared, the order does not matter here. 12 squared plus 6.3 squared. So again, this first part looks very reminiscent of the Pythagorean theorem. So minus 2 times 12 times 6.3 times cosine of A. So again, a couple of reminders here. Keep in mind that these will always repeat. I got 12 here, got 12 here, 6.3 here, 6.3 there. That's always going to be the case in all of these problems. So, next thing that we've got to do is we've got to try to get cosine of A by itself, because if I can get that by itself, then I can just take the inverse cosine of the number on the other side, and that's going to tell me what that angle is. So let's see if we can clean this up just a little bit. So in my calculator, since I know I'm going to have to subtract both of these from both sides, I'm going to do that in my calculator here. So I'm going to do 10.5 squared minus 12 squared minus 6.3 squared. So what I'm doing here is trying to save a lot of the handwork in this problem, because you're more than welcome to simplify this one thing at a time. Simplify the 12 squared, simplify the 6.3 squared, and add them together and subtract that from both sides. But I'm trying to show you the most efficient way to go about these problems. So negative 73.44 equals, then I've got negative 2 times 12 times 6.3 times cosine of A. So we've almost got cosine of A isolated. I've just got to do a little bit more work. So depending on what your fancy is, you may want to simplify negative 2 times 12 times 6.3. If you're uncomfortable putting in a whole bunch into the calculator at once, that's perfectly acceptable. But I'm trying to save as much work as I can here. So what I'm going to be doing here is dividing both sides by this product. So cosine of A times this mess. So I've got to divide both sides by that mess. So that's what I'm going to do on my calculator. I've already got the negative 73.44 in there, so I'm going to divide by negative 2 times 12 times 6.3. If you're going this route, make sure you keep the parentheses around all of that. So divide both sides by that, we get 0.486 equals cosine of A. Let me show on here what I divided by. So I divided both sides by that product. So I get cosine of A equals this. So we've almost got A solved for. So to finish solving for A, I have to remember that the opposite of cosine is the cosine inverse. So what we're going to do to get A is take the inverse cosine of both sides. So over here on the right, when I take the inverse cosine of cosine, since those are opposite operations, the only thing that's going to be left on the right-hand side is A, the angle, which remember is what I'm looking for. So let's take the inverse cosine and get our angle here. So second, got to press second to get to the inverses. So inverse cosine of that decimal here. So it looks like it's about 60.94. So when you get to the online practice, it's going to ask you to round to the nearest degree. So this would round to 61 degrees. Again, when you get to the online practice, it's going to ask you to round to the nearest degree. So round, in this case, round up to 61 degrees.